So let's continue. Question number 6. Please write down the left hand side. So this is an easy sum. Look at the left hand side. Okay, on the right hand side we need 0. Right? So what do you think we should do on the left hand side? What's your first instinct? Okay, let's take LCM. So be very careful when you take LCM. Okay, Raghav, please focus. So the LCM will be the product of the two. So it's going to be cos A plus cos B multiplied by sin A plus sin B. Then we know what to do. This divided by this multiplied by this. So this divided by this is going to be sin A plus sin B. Sin A plus sin B into sin A minus sin B is going to be the formula A square minus B square. So it will be sin square minus sin square B. Similarly, this divided by this and this will get cancelled. So you'll be left with cos A cos B. Cos A cos B multiplied by cos A minus cos B will give you cos square A minus cos square B. So does anyone see anything? Especially in the numerator. Do you see anything that we can do?
So sin square A plus cos square A.
Very good. So that we have sin square A plus cos square A is 1. So we can write that sin square A plus cos square A is 1. And we're left with minus sin square B and minus cos square B. So we can take minus sign common. We'll be left with sin square B plus cos square B. And the denominator will remain the same. So cos A plus cos B times sin A plus sin B. Then we can see that formula comes up again. Sin square B plus cos square B is 1. So now numerator will be 1 minus 1 and denominator will remain the same. So 1 minus 1 is 0. 0 divided by anything is 0. So done. So if you look at the left hand side of question number 7, what comes to your mind? What should we do?
So since we can't convert it directly to tan and cos, we will convert it using to sin and cos.
Okay, so we can use that rule. We can convert everything to sine and cos. Let's do that. So here we have cosec. So we have 1 upon sine A minus sine A. Okay. Another reason why I'm doing that is because see, this and this is same. So probably we can do something about it. And then the right hand side also, if I do the same thing, I get cos A minus cos A. So denominator is same. So if I take the LCM here, I end up with 1 minus sine square A upon sine A. And here if I take LCM, we get cos A 1 minus cos square A. Then 1 minus sine square A is cos square A. So cos square A upon sine A into 1 minus cos square is sine square A upon cos A. Then we can cut sine A and square, cos A and square. So we end up with cos A into sine A. Cos A into sine A. Copy till here first. Till here everyone's fine? Everyone's done with till here? Okay. See the problem here. Okay. It's good that you're trying to figure it out, Abby, but look at the problem. The left hand side that we have got so far is very simple, right? We have only cos A multiplied by sin A. There's not much that we can do. We cannot take LCM, we cannot take common, we cannot apply the formula, we cannot split the numerator. So it's very difficult to go from here to the right hand side. Okay, so this is the first sum actually where we will not be going to the right hand side. We will be solving the right hand side as well. Okay, so you write on the right hand side after this. Okay, since it is very simple and right hand side is more complicated than this, we'll take the right hand side instead. Okay, it's very obvious that we need cos A and sin A. So it's very obvious what should we do here? We have to convert everything to sine and cos. So tan will be sine upon cos, cos upon sine A. Okay. Whenever you have two divisions, okay, the original division will be a main division and this will be a secondary division. So always make a habit of writing the main division first. Alright, the numerator, there's nothing we can do. Denominator, you already got it. Sine square A plus cos square A upon cos A times sine A. Okay. Then if you solve this further, again, write the main division first. Then sine square plus cos square is 1 upon cos A times sine A. Of course, the numerator, we cannot do anything. And we know this, that denominator goes to the numerator. So it becomes cos A times sine A. Oh, is equal to left hand side this time, proved. So see, this is the most different sum that we have done so far. We did not solve the left hand side to get the right hand side. Neither did we solve the right hand side to get the left hand side. What did we actually do? We solved the left hand side, reached somewhere in the middle. We took the right hand side, we reached somewhere in the middle, and the answer was here. Okay, that is cos A times sine. Okay, so that also we can do. And what Raghav asked, that's also a good question. I did not address that till now. That sometimes it might also be required that you start from the right hand side and try to get the left hand side. We always start from the complicated side. Okay. 8. Okay. I'm doing all the difficult questions. Okay, actually I'm doing almost most of the questions only. But you guys have to do the questions, otherwise you'll not understand. So the question looks difficult. All right, I have no idea what to do. I'll take it from you. What should we do? Convert to sine and cos.
Yeah, making that A plus B A plus.
Okay, so I have two options. Either I'll do a plus b whole thing square or that. Okay, let me just think. I I don't want to do what Abigail said. Okay, I'll tell you a reason. What I need to.
So I didn't say anything, they just asked me for any I
Yeah, it's fine. It's okay to be wrong. Okay. See, so what I was thinking is, if I convert directly this to square, right? What Raghav said, a plus b whole thing square, then see, you know that I'll end up with tan square, right? That is very obvious. Now, once I end up with tan square, can I not convert that tan square directly to sec square? Yes or no? Tan square can be converted to sec square. Okay, so that's my idea. Let's see. I can see one more step, but I'll not make it very complicated. So if I just square this, I get 1 plus tan square A times tan square B plus 2 times 1. So it's 1 only, tan A times tan B. Okay. And from this part, I can just expand it as well. So I get tan square A plus tan square B minus 2 tan A tan B. So this is what I was talking about, that we can just cancel 2 tan A and minus 2 tan B. So that way all we have is tan square A, tan square B, tan square A, tan square B. So we will just simplify it and convert it to sec. So convert all the tan to sec. So I'll take this 1 and tan square A. Okay, 1 and tan square A, and I'll write sec square A. Then between these two, tan square A and this, I'm going to take tan square B common. So if I take tan square B, I'll be left with tan square A plus 1. Does this line make sense? No? Uh, so I took this 1, okay, and this tan square A. So 1 plus tan square A will give you sec square A. You got this? Okay. And between these two, that is tan square A times tan square B and tan square B, I took tan square B common. So if I take tan square B common, from here I'm left with tan square A, and from here I'm left with 1. You get it? Okay. So we can see that tan square A plus 1 is nothing but sec square A. So we get sec square A plus tan square B times sec square A. Then we can take sec square A common again. So sec square A, if I take common, 1 plus tan square B. Then 1 plus tan square B is sec square B. So sec square A times sec square B. So question number 3 is very different. Okay, so far I have not seen questions like this in the board. Alright, but it will help us to understand the basics. What does it say? If x cos A plus y sin A equals to m, and x sin A minus y cos A is equal to n, then prove that, we can't write with 3. So to prove x square plus y square equals m square plus n square. What do you think we should do? So we can start with the right hand side instead. Okay. So right hand side is m square plus n square. So as she said, we already have m. So we can substitute. So what is m? X cos A plus y sin A whole thing square plus n is x sin A minus y cos A whole thing square. Okay. After that, it's very obvious. We'll open the bracket. So if you open the bracket, we get x square cos square A plus y square sin square A plus x square sin square A plus y square cos square A. Yes, Raghav? It's correct till here? Yes? Good. Shut up. It's fine till here, Mary? You understand? Kanamisha, do you understand till here? Very good. Clarissa? Nice. Amandi? Yeah. Just now I explained. No. This is a plus b whole thing square. So it's not going to be a square plus b square. What is it going to be? A square plus b square. And what is missing? Plus 2ab. So 2a is x cos a times y sin a. And here 2x sin a times y cos a. So after that, we're going to take common. So I'm going to take common between x square cos square a and x square sin square a. So between these two, if you take common, then we get x square cos square a plus sine square a. It's very obvious why we're taking common, because then this will become 1. Okay. Similarly, we're going to take common between this and this. So between those two, I can take y square common. So y square, if I take common, I end up with sine square a plus cos square a. And obviously, this and this term will get cancelled. Then cos square plus sine square is 1. So we get x square into 1. Y square into 1 will be y square, which is nothing but the left hand side proved. So let's see some PYQ questions. Please copy question number 7. Copy the entire thing, okay? Raghav?
Sorry.
No.
So A plus B whole square. A minus B whole square and something is
Okay. You break. What are you doing with the pen? It'll break. Acha. So it's given only what to do, right? So let's do what's given only. So just square everything. So we get 1 square plus sine square theta plus 2 into 1 into sine theta. Then if you square this, we get 1 square plus sine square theta minus 2 into 1 into sine theta. Okay, you don't need to do the way I'm doing. If you can move directly to this next step, also you can do cos square theta. Okay. After that, this term and this term is same, so they get cancelled. Between, I can just add 1 plus 1 is 2 plus sine square is 2 sine square theta upon cos square theta. I can take 2 common. I get 1 plus sine square theta upon 2 cos square theta. I can simply cancel 2 and 2 and we get 1 plus sine square theta upon cos square theta. Mary, I'll start with you only. Mary, what should we do? Very good. Are you practicing, Mary? Nice. Good. Very good. Try solving this 26 on your own. Listen. All of you have done in a very different way. Okay, I like that. Ananya has done very differently. Raghav has done very differently. Right, but both are correct. But let's learn something basic, all right? Okay, now listen. So, first of all, we can see this directly, right? Tan square plus 1. Now, tan square plus 1 is nothing but 1 plus tan square. Same thing only. So, 1 plus tan square is sec square. So, we can directly write sec square theta, right? But for this one, see, you have the formula sheet. In the formula sheet, you have that 1 minus sine square theta is equal to cos square theta. Yes or no? So what will be sine square theta minus 1 equal to? Minus cos square theta. Right? So how do we come up with this? Imagine like taking minus common from here. So if you take minus common from here, then what do you get? Minus 1 plus sine square theta is equal to cos square theta. You can always take minus sign here and we get minus cos square theta. Okay, so basically you remember this as another formula only. Basically when the terms are interchanged, in the formula we have 1 minus sine square theta. But if the terms are interchanged, that is sine square theta minus 1, then the answer will be negative. Okay, so this will simply be minus cos square theta plus 1. After that, this I can convert it to 1 upon sec square theta into sec square theta plus 1. Cancel, cancel, minus 1 plus 1 is 0. Okay. So, but your method is also good. Keep it that way. The way you did was also nice. Like, this is something that you need to learn in trigonometry, okay? That you don't have to do it with my method or any teacher's method. Like what Ananya did is that she did not see this, that this minus this will be minus cos square theta. She went around.
That's right, but I still want to be minus.
Let's pretend you didn't for the video. So what she did was that 1 she converted to sine square plus cos square, and then sine square got cancelled and you got minus cos square. Okay, Raghav did a very nice thing. I have never seen. What did you do here?
So that sine square theta, I kept it as it was. Then so that tan I converted into sine and.
Oh yeah, yes. From here you got 1 plus sine square theta.
Sine square theta.
1 minus sine square theta, and 1 minus sine square theta, 1 minus sine square theta, you cancel with this, no? Very good.
No. According to that. So for sec square right theta, so will it not be minus there also? Because that tan square theta plus 1 is also interchanged, right?
It's plus, no, Raghav. Plus, there is no difference. No. Yeah. Okay. Question number 34. Please try question number 34. What's your plan? What are you going to do?
So that cos A minus sin A, right?
Yes.
I'll convert cos A into 1 by sin A. Then I'll take LCM. Then so for the sec A, I'll convert it into cos A. Then I'll take LCM.
You can do that. Try to reduce the number of words that you answer. You can just say, I'll convert everything to sine and cos. No. Ready? Alright. So question number 2-1. So in the left hand side, what we will do here, we will convert this to sine and cos. So sec will be 1 upon cos A minus sine A upon cos A times 1 plus sine A. Now here obviously we can take LCM. Say what is squared? So LCM will be cos A 1 minus sine A whole thing square times 1 plus sine A. So after this step, it's a little complicated. What do you suggest I do? It's a little difficult to see.
So you will do 1 by sine square A by cos square A.
We can't do that because this is whole thing square, no? It's like A minus B whole thing square. So it'll be A square plus B square minus 2AB. What else can we do? See, let me do this. Since it is a square, okay, I'll explain in a simple way. Since it is a square, let me just write this 2 times. 1 minus sine A divided by cos A into 1 minus sine A divided by cos A multiplied by 1 plus sine A. Okay. Now, why are we doing this? You see, it's nothing but this multiplied by this multiplied by this. So here you see we have 1 minus sine A and here we have 1 plus sine A. So what is 1 minus sine into 1 plus sine? 1 minus sine into 1 plus sine will be
1 plus sine, 1
minus sine square A. So we can write 1 minus sine square A upon cos A into cos A will be cos square A. And what are we left with? We're left with this. So 1 minus sine A. Do you see this is nothing but our right hand side? Isn't it? Now it's very easy. What can we do here?
So cos square
1 minus sin square is cos square a, and then we can cancel. Then we're left with 1 minus sin a. So we're left with 1 minus sin a, which is nothing but the right hand side. I think you can make out why have I written this formula here. Can you make out? Okay, what?
So that cos cube A, that cos is A and sin is A.
Yes, so we can apply the formula. So here what will we get, Raghav?
So
Cos A
plus sin
A.
whole thing square, then
No, we don't have both things squared.
then cos cube, so that's 3, right? Cos cube A.
No, this.
So I'm talking about that. Cos cube A will be there, right?
Which cos cube A?
Yeah, cos cube A.
No, we're applying the formula for this one, no? So this is like A cube plus B cube. So what is the formula of A cube plus B cube? A cube plus B cube is A plus B into A square minus AB plus B square.
No, cos A.
Yes, cos square A.
This one was minus cos A.
Minus
Cos A
cos A
into sin A
into sin A
plus
plus
sin square A.
sin square A divided by, let's keep this as it is, that is cos A plus sin A.
So for this one, so it can be A plus B, A minus B also.
Yes. So this is A cube minus B cube. So we'll apply A cube minus B cube formula. I don't have space, so I'm going to write it here. So it's going to be cos A minus sin A into cos square A plus cos A times sin A plus sin square A divided by cos A plus sin A. So do you see what can we do here? This is not plus, this is minus. Nobody says what can we do here? Yes, good. Elena, we can just cancel, no? This and this. And this and this. See, we have eliminated the denominator.
Oh yes.
Okay. So then what do we get? Here you see we have cos square plus sin square. What is cos square plus sin square? 1. So minus cos A times sin A. And here we have cos square plus sin square. So again, what is cos square? Cos square plus sin square? 1 plus cos A times sin. Then we can cut this and this. 1 plus 1 is 2. So the only difficult part here is the formula. If you know the formula, then it's simple. So let's convert everything in terms of tan. We'll see why are we doing that. But let's convert everything to tan. So this will be tan A upon 1 minus tan, 1 upon tan A plus 1 upon tan A divided by 1 minus tan A. Then here in the denominator, I can take LCM. So the LCM will be tan A, and here I'll get tan A minus 1. Numerator remains the same, that is tan A. Let's look at the second term. In the second term, this tan A will come down. So you'll end up with 1 by tan A, 1 minus tan A. Let's take it slowly. This tan. Okay, do it. Take your time. Let me know if you understood or not. We know this already, we have done it so many times, that the denominator's denominator will go up. So it will become tan square A upon tan A minus 1. Now here I want tan A minus 1, but I have 1 minus tan A. So what we can do is we can take minus sign common. When you take minus sign common, this will become minus and this will become plus, because whenever you take minus common, the sign changes. So I'm going to take minus common. So that will make this sign minus, and you'll have 1 by tan A minus 1. Okay, again, this step is also different. If you don't understand, let me. Yes. Let me do this step separately, okay? I know many of you will not understand. So just focus on the denominator for now. Okay? Imagine that I take minus sign common from here, right? So this will remain the same. From plus 1, if you remove minus 1, then it will become minus 1. Yes. And then from minus tan A, if you take out minus, then it will become plus tan A. Do you get this step? Then after that, we will just reshuffle them. So we get tan A minus 1. I want to write this term first and this term next. You got it? Okay. This is something that we'll be doing very often in class 10. So you can just remember this step also. That if you take minus sign common, then these two will interchange their position. Okay? Till here is very difficult. After that, it's easy. So till here, did everyone understand? You got till here? Then we will take LCM. So you see, why am I doing that? Because I want tan A minus 1 on this side as well as tan A minus 1 on this side. So the LCM will be tan A times tan A minus 1. Now again, if you remember the basics of LCM, it's this divided by this multiplied by this. Right? So what will we get? Tan A into tan A minus 1 divided by tan A minus 1, what will we get? This, when we divide by this, what will we get? Tan A. That tan A multiplied by tan square A, what will we get? Tan cube A. Minus here, this and this is same, so nothing will change, we'll get 1. Now who can tell me what should we do on this side? Yes, what do we do here in the numerator? Who can tell me?
So we'll take
Formula. So this is A cube minus
B cube.
B cube. So what will we get? Tan A minus 1 into tan square A plus tan A into 1 plus 1 square divided by tan A minus 1. Then we can cut this and this. So tan square plus 1 is sec square. So I can write it as sec square A plus tan A divided by tan A. After that, we will split the numerator. So we end up with sec square A divided by tan A plus tan A divided by tan A. Then we can cut tan A, we get 1. See what will we do with this. So here we will convert everything to sine cos. So sec square will be 1 upon cos square A divided by tan A is sine A upon cos A plus 1. After that we can cut cos and square. So we get 1 by cos by sine. So 1 by cos is sec A and 1 by sine is cosec A plus 1. That is the right hand side. Yes, anyone who did not understand? This one? This one?
So what was that one name?
We cancelled 10 and 10, we got 1. Okay, are you guys deliberately doing this? Well, let's waste time.
So the law of
So we have to solve quantum mechanics.
This one? This step. How did I get this step?
Once you get answer, that's right.
So this step. Okay, see. Okay, shh. Let's do this. Let's break it into 2 steps. Alright, you'll understand this, Amanda. I know. What is 1 by cos? sec A. So imagine that I do it in two steps. So I write sec A upon, what am I left with here? Sin A. Do you understand how I get this step? This step you get it? Okay. Now sec A, I'm keeping it as sec A only, and 1 by sine, I'm writing it as cosine. You got it? What do you think we should do?
So LCM.
LCM, okay. I'll take that. Anyone else? What should we do?
Tan to sin cos.
Very good. Convert tan to sin cos. Why did you say that? Okay.
Sin will be
Very good. Okay. Because on the right hand side, you can see that we have only sine, right? Any other reason?
because we don't know what to do.
Yeah, because we were, yeah, very good. So, see, one more reason is that when you convert sine by cos, do you see that it will be easier to take LCM? Now what? Let's open the bracket here. So we get 1 square plus sine square A plus 2 sine A. Yes. Yes, yes. Zishan, in our language, we have a saying that if you laugh a lot, you end up crying a lot.
I feel like this everyone's language.
Don't cry again. Don't cry again, Robert. So Raghav was asking why this A not. He knows that.
No, you're not asking me, just shut up. Okay, then we take the LCM, right? Let me just finish this, Yeah, what do you do? Common, and then?
Then so we get one very fast science book. Convert it into cost. Cost by will get cancelled. What is feeling?
You know you're loud, right?
Something wrong.
And you know it's a small room.
So I like one thing, right? We are allowed to do both left hand side as well as the right hand side together.
Yeah, that's what I did.
Like from the starting.
Together, though, how will you do? Like this?
Like you both starting with left hand side,
That's what I did.
then doing the another.
That's what I did.
Okay. So right the left hand side equals to right hand side, you just solve it.
Oh, like that?
So it's not that hard to understand.
The right. So are we allowed to do that?
No. See, we're not allowed to do that. Okay, we cannot, for example, if you have to show that, 2 plus 2 is equal to, let's say, 3 plus 1. You cannot write 2 in the next line. You cannot end up writing like, the moment you write this line, you're already assuming that it's equal. Yes or no? On that basis only you're solving. You have to prove that they're equal. So you'll have to take this separately. You'll have to take this separately. The moment I write this line, no, I have made a mistake. Why? Because the question is asking us to prove that they're equal. When I write this line, I'm stating that these two are already equal. So that's the mistake. You got it?
So no one knows it. Your channel. So.
No one knows my channel?
The whole now.
Huh?
The whole.
I got a comment from a girl in the video that is not from the tuition.
So,
Raghav.
sorry. So,
No.
So A plus B whole square. A minus B whole square times something square.
Key concepts.
So if you square one, so you get one.
Let's try question number 4.
So then we get one.
Yeah.
So the sec A by sine A plus 1.
Yes.
How do we get the sec A?
See. Let me write one more step. Okay. Can we write this as sec A into 1 by sine A? Can we write this thing as this? Would you agree that this is the same thing?
That's not equal, that's plus 1.
Yeah, it's plus 1.
So that one can change it to me.
This one, this is also plus 1.
That's not like plus 1.
You guys are tired.
No, that's not that question. So that's active way, right?
Hey,
So that's active way, right? Minus 1. So you have applied the formula, right, of A minus B. Also in that one, so there's no, so you apply the formula. That one, so-
happy? Cubist? One cubist?
Can you cut this part from the video?
What do you think? What do you think? You guys are laughing like. What? Last? What do you? How you guys are messing my video so bad. You just think about.
I think it's Robin.
My bad. My bad. I did not write C properly. Okay, but LCM, cos and cos, you did not cos.
Oh, the looks like A.
Fine, my bad. My
Your
bad.
bad.
My bad. But then cos A and cos A, the LCM will be last A.
So this will be clarity for the video. So you can comment why this last.
How many of you have started practicing trigonometry at home?
No, it's not, sir. But not this.
Just started, no?
No. Started to be. No, sir. I started outside.
Where? How many sums have you finished? He knows his right.
No, sir. I will show you. You show me right. No, it's not happening.
Others, how many of you have started? You haven't started, I believe. Have you started, Kamisha, trigonometry? How many of you finished? 4, 5, 6. Is that it done? Not started yet. Ready? Started. How many have you finished? First exercise you finished? Good. Not yet. Are you done with the project?
Yes.
Very good. You're in the third sum. Sorry? About. About. Why? You're not able to count from 1 to. Huh? About, how is it? About 3. 2.5. 2.7. That's the response when I ask you how many chapters you have finished. You say about 3. Not how many sums.